Okay, I'm just going to play it as a slideshow because at least on this slide I have a GIF to show. Have you guys seen this Simpsons episode? It's one of my favorite kid jokes. So Homer is trying to build a barbecue pit kit, and there's no voice here, but he says, "Why doesn't mine look like that?" So this is sort of my experience with more difficult kids. Okay, so I wanted to talk about Meccano, which I've been playing with quite a bit. Is everybody here familiar with what Meccano is? Have you guys played it? No? Okay, so Mayor has, Anuraj hasn't, so that's actually, I think, kind of revealing, because I think sometime in the early 80s, there was a watershed where Lego, I think, overtook Meccano as like the most popular mechanical kit system. But Meccano is probably the oldest kitting system in the world that I would call industrial age. Like before that, if you had like kit-like toys, they would be more, I think, farming style. Like you've seen Lincoln Logs probably, that allows you to build like a cabin-like thing. So it's, I think prior to about 1880 or so, kits are more architectural, so you can make buildings and stuff. But around 1890s, you start seeing kits that can build machines. And Meccano, as far as I know, is the first serious one, patented in 1898. So I did some Googling and I found all these interesting things. The one I had as a kit is, that's my, I don't know where my cursor went. I'm actually going to escape this since you already saw the 6. Okay, this one on the top right, the one I had as a kid in the early 80s kind of looked like that. At that point, they still had like slotted screws instead of Allen wrench type screws. But this was news to me that in the 1970s, the kits came with like, you could buy steam engines for the kits. So this is like pre-robotics, like true early industrial age steam power kits. I'd actually be curious if I can get one of these off eBay or something. But if you Google Meccano, you'll see people have made really huge, extremely complex things out of Meccano, like almost full-size steam locomotives and stuff. And you can buy like classic kits. The expensive ones are super expensive, but the corporate history is kind of interesting. It started in Britain. There was a kind of knockoff in the US called Erector that eventually merged with it. There were knockoffs all over. These kits became hugely popular in the Soviet Union. So the entire Eastern Bloc, if you talk to Russians of a certain age, my age or older, they will all be familiar with Meccano. They were super popular in India when I was growing up. Legos were not easily available. Legos were both more expensive and came, I think, a little later. Okay, let's see. This is what Meccano looks like now. It's relatively small. It's been acquired and sold a bunch of times. So I think the British company sold it to a Japanese company in the 80s, which then sold it to a French company. And then now I think a Canadian company owns the merged Meccano Erector thing. So this is the kit I just bought in December. It's a 25-in-1 super construction kit. It's the most expensive one they have. But the other kits they offer kind of all look like the what do you call them? The RC kit cars that are like all-terrain heavy wheels thing. I think Ian bought one of those, Victor bought one of those. So it's kind of like trying to merge with that. I think if you go to the Meccano site, you'll see mostly the off-road car kits. You won't see a lot of these classic crane and industrial equipment type kits. So that I think tells you something, that the off-road RC stuff is getting more popular. But okay, so just some glimpses of what it is like to build with these guys. So this on the top left is the first model I built, and I started doing this little experiment where I wanted to see how many of the components of each model were reused in the next one. So I started breaking it down, taking photographs, and seeing like how much of that was reused in the next model in the sequence and how many more parts I had to pull from the box versus put back in the box. And I started thinking an interesting sort of game you could play is when you break down a model, you reuse as much as you can in the next model, but then any leftover parts, see if you can like design like a leftover thing with it. Now, see if I can, what's the format? I'm actually going to go back to view, sorry. This might be easiest to see. Yeah, so these are the first couple. So the first one is a kind of like catapult. You use almost, so this gives you an indication of how much you end up reusing for the second model, which is that simple car with like a fake rotating radar kind of thing. It's kind of like a, I don't know, Mad Max type car. But compare the middle picture over here with the one on the bottom right to see how much is left over. So that gives you an idea of how the space evolves. So continuing, break down the car, you get quite a lot more parts. That turns into a crane, and then you get those leftover parts. And then if you break that down, this was a very interesting model. It's a military style swivel bridge. It swivels and turns into like a bridge. And this is kind of the logic of the kit. It gives you 3 routes of construction pathways. I'm on the first one labeled 6. So I did the catapult, I did the little car, I did the overhead crane and the bridge. And the last one I made is this thing that's basically a rover. This is the first one where you add the motor that comes with the kit. I'll talk about it a little bit, but I don't yet know the logic of these sequences, but it does seem like they build on techniques. So techniques you learn in earlier models are reused in the next one. So the overhead crane is the first one to use high load vertical roller bearing. So it's a disc shaped roller bearing. Let's see if we can go. Yeah, if you look at the crane and the swivel bridge, both of them rest on a roller bearing that you construct out of like 20 little plastic rollers and 2 plates and a shaft and a brass collar. But that's a fairly complex subassembly to build. So I think what they're doing with the construction sequences, you learn how to do some fairly complex assembly, and then you reuse that subassembly skill in the next model. So I think that's the logic. And with the rover I just built, it's the first time I'm using the motor and battery. And then you have a plane, a forklift, something that looks like a vertical robot, a helicopter, and then something that looks like a race car. This next sequence, I'm not quite sure what that is. The most complex model looks like it's in the middle, the overhead crane, but then the arrows show it going out towards less complex models. So not quite sure what's going on, but I guess I'll learn. And then the last one is another circuit. So anyway, 25 models, and I was quite impressed by the range. I would say it's not counting the fasteners, maybe there's like 100 parts here, but it can make this extremely wide range of models. And I was thinking, if you want a kit-based rover system for Mars or any like wilderness terrain, this would be actually a nice little expressivity range to have. Like maybe you want to dismantle your rover and make a forklift truck, right? So quite interesting.
How much of the 3D printed stuff can you like you bolt onto this? A lot, right?
This is out of off patent and it looks fairly standard. I actually did try to 3D print some parts. Let me grab that actually.
Push. This better.
All right, let me stop sharing for a second so you guys can see my screen here. This is the current shape of the rover. It's basically a single motor with a primary pulley drive that's then reduced. So there's 2 of the same ratio. So it reduces, I would say, 1:50 via 2-pulley or 2-belt drive thing, and it's not super strong. It's basically the control is basically the switch up top over here that is forward and reverse. And one of the things I'm thinking of doing, though I hate like damaging kits, is to just cut this wire and splice in basically a header for shoving in an Arduino or something, because the top is actually quite nice. You could like bolt any board onto it, cameras and stuff. So this is a very capable chassis. I'm actually surprised that they made the robotic parts so limited. It's just a battery and a motor with a direct cable. So it would be fairly easy, I think, to snip this and put like, more sophisticated controllers here. So this is the current rover. And it's.
And why can't you build your own cable? The
battery pack is nice. The battery pack has some nice sort of mounting screws and stuff, so I'd like to reuse that. But yeah, I can also like just do the whole thing myself. This is one of the reasons I was asking about what are people's ideas on basically adapting a modular bus or a wiring system to this kit, where you have these 25 models that you can make. Can you actually create like rigid composable power and signal buses that kind of go along the construction lines geometry, and then anything you do, any sensors, motors you add, you can kind of assemble the bus alongside it and then connect it to the board. Yeah.
What you're saying is a modular electrical system that you can integrate with a modular mechanical system.
Exactly.
Well, I presume you'd want to use a bus, like the CAN bus.
I don't know much about buses, so maybe that's a good topic for us to discuss. I was thinking something like I2C is what, about 25?
Yeah, okay, it's another bus.
Yeah, and that's a single wire, right? And I don't know how many conductors it takes to do any of the other buses, but yeah.
What is it, 445 also?
Okay. So this is a topic I'd actually like to schedule for future discussion, because if you remember, I think a couple of years ago, one of my first talks was on wire harnesses and how messy mine got. So it would be, this is like a common bottleneck, I think, where people stall. So if we can come up with a really good and easy composable wire harness and signal and power bus thing, it'll be really good, because mechanical stuff is good. Yeah.
So you will have a three, for. So I2C is mainly used for on-chip peripherals, and then you could either use CAN or LIN. CAN is much more complex, and then it's basically used in cars for low-speed communication. And then there's something called LIN. It's basically UART, but with a differential voltage leveling. So, and then you can, it's like a low-speed CAN. You can say it's less complex than, and you also get simple ASICs or small ICs which do all the protocol things for you, and then you can communicate with your microcontroller with the chips or with the simple I2C or like UART.
Okay.
Just
and
remember
there's something also called Canduino. So the CAN chip is already integrated on an Arduino. So there's also something called that, like that.
Exactly. So it's only 2 wires. The real question is, how difficult is it to add a sensor onto it? Not how difficult is it to talk on it.
So I forget which bus I looked at. I think it had 4 conductors, and it would be able to do like, the usual simple sensors and LEDs and things like that.
No, but the question is, I have a sensor. How do I attach it to the bus, whichever bus it is? I need some sort of adapter.
Yeah.
So if the adapter is a simple chip, all well.
So this is where I think it would be interesting to design mechanical mountings that are modular. So it'll be like, okay, you asked about 3D printing, Anurag. So this is one I printed, if you can see in my camera. It's basically mechanical compatible. So this would be easy to do in plastic. Metal would not be very much harder, because these are relatively thin metal strips that you could probably, I don't know, drill with a Dremel or something. And by the way, there's a whole cottage industry of people who just stamp out metal parts, mechano-compatible ones for you. But it's surprisingly, I think Lego has taken over so strongly that it's not very popular. So there's a few like eccentric hobbyists in like Britain and New Zealand who do this stuff. But this doesn't look hard to me. Like I think it would be really hard to make your own Lego parts that are like strong enough to even hold with Lego level strength because the tolerances are really tight. But strips with holes that are fastened with fasteners, I think anybody can do.
So what is patented in this? The distance
Nothing.
between the
It's
hole.
old enough that everything is patent off patent. So anybody who wants can just make their own metal parts. I think Lego is also off patent, so people make their own Lego, but
Yeah, but they do have trademarks on
Yeah.
some of the shapes. In some countries you can get, in some countries you can't. So you just got to be careful.
yeah, they just call it different things and they've sued some people. But Lego, I think, is fundamentally less friendly to sort of open hobby sort of level stuff because since it doesn't use fasteners and uses like strong press fits, the tolerances and the plastic stuff, I think, is beyond what most people can 3D print. Like I think the 3D printing would be really crappy for Lego. So anyway, I was like, this is like 30, 40, I think, yeah. I last played with it when I was like 8 or 9, it's almost 40 years. That's this. I'm really impressed by how good Meccano still is and how friendly it would be to rover type hardware. So I'm going to play more with this, but moving on.
No, the kit you made, is it squeaky or is it like really rigid?
It depends on which parts you use. This one is pretty robust and well done. You can tighten the fasteners to high torque, so it'll stay pretty solid. The motor is a little weak. Maybe I should replace the batteries. My batteries are old, but it was not strong enough to move on carpet, but it was okay for moving on hardwood. And I think the drive is not super strong. Like maybe the axle stuff is not properly done. I'll have to revisit. But you can, I haven't found kits with gears, but there are historically lots of Meccano compatible gears. So I'll go hunting for them. And of course, you don't have to use drivetrains. You can use like gear motors on individual suspensions. And like, you know, the older rover I built is 4 separate drive motors and 2 servos. So you can just do that instead. But what this gives you is a very flexible, larger geometry capability. So you can build lots of stuff. I'm going to try and make a 6-wheel rocker bogie out of this kit if I can and see if that's possible at all. But I was impressed with the 25 models the kit can nominally make. This is an extremely wide variety here. Okay, let's talk a little bit more generally about kits. This is a kit my wife found in a swap meet. It's a clock, but it's a good example of what I think is a bad kit because almost 90% of the complexity is kind of like pointless aesthetics. It's a Zodiac themed clock, and all of the complexity you see is basically greebles, as they call it. It's like weird little aesthetic flourishes, but the actual clock part is you don't get to build that. The kit comes with a regular clock movement that's just, you know, shove in a battery and attach the hands and put it into this framework. So you're not actually building a clock. You're building like a complicated piece of art around the clock. So this is another kind of kit. It makes only one thing, and the hardest part that you might want to research is not actually part of the thing you build. Here's another kit I've built, which is a pendulum clock. This, I think, is in between something like Meccano, which has like a lot of expressivity and can build 25 very different things, and something like the ornamental clock. So this is a real clock. You build the actual pendulum mechanism with real gear trains and stuff. You also build your own tooling out of the same laser cut wood sheets. So that's, I think, an interesting thing to think about. Like the Meccano kit comes with its own spanner and Allen wrench. So I think an important part of like more complex kits is it should either allow you to make your own tools or sort of come with tools or use extremely simple tools. So bootstrapping tools is interesting. And these are non-trivial tools. They're like ways to fit parts to like precise depths and stuff, but it makes its own tools. So that's kind of interesting. I also thought this belongs in the universe of kits. So I looked around on Amazon and I found this random $10 bag of parts, basically, they look like leftover gears and axles and pulleys from toy cars that probably some factory in China had as like, extras, and they bagged it up and decided to sell it. But it struck me that in some sense, if you create a design space of possible kits, this is like the high entropy leftovers corner of kit space, whereas Meccano is like a very carefully curated part of kit space. Okay, so this is a slide I had in the talk I did last week, like what's good kits over bad kits. So some of the thoughts I had, like, I think the reason that first clock I showed is in some sense a bad kit is that it gives you a single goal that you have to converge on, and maybe you can adapt the kit for slight deviations from that, but fundamentally it can build one thing and nothing else. So it's not really a kit in a true sense, in my opinion. A true kit should make at least 3 or 4 fairly different designs. It should not be just one thing that you build up. I like the idea of scavengeability, as in like you can, this is related to, I think you introduced me to the notion of kit bashing, Mayor. So you should be able to like take related kits and put them in a larger pool, and you don't add too much entropy, but you add significant expressivity. And Meccano is pretty good. I started augmenting it already. Like, for example, the axles and assemblies for creating wheels, it's pretty friendly to adding springs. So I'm trying to like invent a spring-based suspension because I have some springs lying around, and that seems easy to do. So you should be able to like expand it through that kind of like augmentation. You should be able to explore a design space very thoroughly instead of like, efficiently. You want composability over like functional fitness. And by that, I mean something like, it's okay to not have the best rover if it means you can like, tear it down and build a forklift instead of like a super optimized, really good rover. You have like a mediocre rover that can also be a mediocre forklift. So I think that's a good feature to have. Yeah, I don't want to talk to this whole slide, but I had a bunch of talking points I was thinking about. Oh, ergodicity over non-ergodicity is kind of interesting. So if you guys are familiar with the statistical notion, a system is called ergodic if you take the average of all the sort of elements of a set, and it's equal to the average of a single element over time. So for example, if you have particles of gas in a box, the average of all the velocities, but by this I mean if you take 25 instances of the Lego kit and people are building 25 different models, in some sense an average of all those models is the same as the average of the different models a single kit could be over time. So it has that ergodicity property, which is because it's reversible. You can disassemble and reassemble in a very reversible way. So I think that's an important property of kits. All right, so I don't want to get too much into this. But yeah, after I started thinking about like what are the good properties of kits, what are the affordances, I was thinking what's an ideal kit? And I just 3D printed this guy. Have you guys played with tangrams?
Yeah, Venkatesh, can you go back to the previous slide? One of the things you talked about with the Meccano is that you thought that it went from model after model, and each models that you build, you learn something about how to make more sophisticated models.
Yeah.
I don't notice that you put that in your list of dispositions. You don't think it's important in a kit?
Yeah, so that's probably something like learnability, right? Yeah, that's a good point.
It's more than that. It's stepability. In other words, I can have small steps. The first step has to be small, and the gap between steps has to be, usable. So
Yep.
I'm just wondering if that's an affordance or a disposition. I don't know.
The disposition list is basically pairs of terms, like a good kit versus a bad kit, or a good kit versus a good not kit, because it's not that kits are the perfect way, but the opposite of a kit is a very integrated, tight, and irreversible design, right? So yeah, I think this belongs in the affordances list. But yeah, the reason I thought of it as like the Zen of kits is it has one very interesting property that most kits don't have, which is that you use all the parts in every design. And if you've played with this, it's like, I don't know, elegant enough that almost any way of putting the 7 pieces together gets you something interesting, either aesthetically interesting or like symbolically representative. And this is kind of interesting. I actually tried hard to like put it together in a way that was ugly or completely meaningless. It's hard. Like if you follow the rules, which is you must use all 7 pieces, they must be touching and they cannot overlap, you'll generally get something that looks kind of interesting. All right. Oh yeah, Jenna's point in the chat is a good one. There's a video shared in, I think, the fitness channel about a coach teaching a kid how to do a backflip with like an extremely broken down step by step. And even though it looks like magic when it's done, the learning path is like super steppable. All right. Okay, I wanted to talk a little bit about Lego, and if you are on my newsletter, you saw that I went on a little rant about it in my last post. But after playing with Meccano a little bit and remembering I haven't played with Legos in a while, but then remembering, I kind of concluded that Lego is in some ways a bad kit for a couple of different reasons. One is they sort of perfect the design in a way that makes this almost like a computer game. Like this is like Minecraft. It takes away all the friction and messiness and compliance and tolerances of the real world that Meccano keeps in. But the other kind of like, I don't know, I guess it's a opinionated design aesthetics point. Most Lego kits have extremely strong themes. So they're closer to that ornamental clock than to the 25 model Meccano kit. Like I've seen 2 kinds of Lego kits. You either get these, I don't know, unthemed assorted parts buckets. So it's an entire bucket with like basic bricks and then no guidance at all. Or on the other extreme, you get something like this. So this is, I guess, a French Revolution themed kit with like a guillotine and like a, I don't know, prison cart and an executioner. It's like cute. You can, I don't know, set this up and tell a little puppet show type story. But this is not super flexible. I mean, the range of expressivity around this like prototypical way of building the model is not much. And I remember I had 2 kits as a kid. One was a helicopter kit, and you could make like a windmill with it, but not much else. And the other was a smaller, like little car kit that you could like do a couple of things with. But fundamentally, it was like, I don't know, too strongly focused on 1 or 2 goals and like maybe a couple of variants around it. But beyond that, it's hard. But
No,
if you, yeah,
I beg to differ. I beg to differ. When I was a kid, I got one of these small 4-digit helicopter kits, and I built a robot out of it, a humanoid robot, you know, about this side, legs, and so on. And the 2 things, and of course, it bear no resemblance whatsoever to a helicopter. I had a few pieces left over. But what I remember was that even though Lego is very strict, most of the pieces were general purpose pieces, and at the edges, they were multifunction. So if you take 2 long pieces and attach them only at one point, you can get a joint.
Yep.
For example. And so in that sense, I felt it was a good kit because I could build something completely different with it. And it wasn't true that each piece could only do one thing.
Yeah, that's
Each
not,
piece had,
it's not that each piece can only do one thing, but the whole.
no, in the whole kit, you know, a robot, a humanoid robot, and a helicopter. It's completely different.
Yeah. I think it's on a spectrum. I do think it's at least the ones I've played with.
Not this one. Not this one. This one you can't do
agreed.
anything with. Yeah.
I also had like a simple helicopter kit, and I remember most of the parts were general purpose. The one slightly not general purpose was the core of the rotor, which was like a cross shape
Right.
that would fit on a pivot that would allow it to rotate. And that's why you could make a windmill out of it, for example. But yeah, there's generality, and I might be overstating the point, but this is not so much a feature of the kit system as of the kits they choose to sell. And actually Meccano is going this way as well. They're selling more and more of the race car or off-road vehicle type kits and fewer of these sort of general purpose kits. But yeah, I think that's partly maybe what kids and hobbyists want. They want like one really well done thing, like, Star Wars or French Revolution. And they don't care as much about expressivity. So yeah, I think Lego fundamentally could be as expressive as Meccano, apart from like, the not teaching some of the messiness of real world engineering. But the product company has chosen to make it much more, I don't know, themed. It's a good discussion topic though. But apart from that, I think for rover research, unless you're willing to spend a lot more money, like the video you shared of the guy doing the really complex drivetrains, I think those parts are super, super expensive. Like my Meccano kit, the whole 25 model kit is like, I think $75. And I think if you buy like a full set of parts that can do what that guy did with the various Lego drivetrains, that's probably going to cost close to $1,000, because those Technic type Lego parts are not cheap, as far as I can remember. I never had a Technics kit, so I don't know. But yeah, I would say if we want to recommend to new members of the rover group, if they're interested in exploring hardware kits, Meccano might actually be a good foundation to build on. All right. Oh yeah, so talking about the kits we've been sort of already exposed to, I think Eric had, after the High Wonder Spider, he bought the tank. I don't know if he actually built it. That's one of the RPI cars that's available on Amazon. I think there's a whole bunch now. And surprisingly, I couldn't find the two-wheeler Jetson bot that Sai was building on Amazon now. But there's now a whole universe of things you can build with Jetson, like a really impressive array. Though I'm not sure I want to call these kits on the hardware side, because it's almost designed to like get you out of playing with hardware as quickly as possible so you can focus on the programming and electronics part. That's the impression I get. Like this is for people who don't want to fuss around with like friction and wheels and drivetrains. This is for people who want to play with the Jetson piece and cameras and so forth. Let's see what else. This is the electronics kit I bought 3 years ago, and it was quite good. It's the Elegoo, what is it? Basically the Arduino Mega ripoff, and it came with like a fairly complete set of parts, lots and lots of sensors and resistors and capacitors and stuff. And yeah, this was better than anything I had as a kid. I don't think I had an electronics kit as a kid. I had an electrical kit, but no electronics parts. So this was quite good, but I think electronics is fundamentally more messy than mechanical. So I think that's something to do with like the physics being way more complex and expressive. I also wanted to like, do you guys remember the 555 era, like before Arduino took over as the big central hub of all electronics projects? People used to mainly build projects around things like the 555 chip. I remember building at least one very simple one, but there's something here. I think we talked about it briefly a few sessions ago, but the microcontroller Arduino era, it somehow moved a lot of the electronics logic and complexity away from hardware components and into software. Like right now, I would say electronics projects are keep the peripheral rim of sensors and actuators as simple as possible. There's not much going on there. Feed it all into GPIOs of Arduino and do almost all your heavy lifting in the Arduino or higher level of abstraction. But there was this 555 era, and I was not like deep into it, but I had friends who were. And I don't know, maybe you guys have thoughts on this phase shift. Do you guys remember this? Like, do you remember the 555 era?
Well, I had it in courses, but I have never made anything. Basically, for me, it was basically a simple oscillator with less programmability. You can get all the functions in software, and it's quite flexible in software than building it with hardware.
Yeah. I remember projects built around 555s were simply like visually and physically more complex. Like people would have way more parts and resistors and capacitors and crap on a board to get, fairly simple electronics projects. Whereas today, if you look at something built around an Arduino, you have the Arduino and then maybe a couple of breakout boards with a few components, but things look relatively simpler in my opinion. So that I don't know, that's something to think about. Like, okay, I would pose it as a debate question. If you wanted somebody to like research the electronics hardware side of rovers, would you rather give them a kit of relatively simple components like 555 and similar, or would you pop up to the microcontroller level of abstraction, or would you say let's go Raspberry Pi and higher, like full single board computers, and like basically keep the electronics as dumb as possible? So I don't know what I would recommend. I don't have enough taste or intuitions here.
No, I would definitely recommend going with a higher level, because what's interesting in robotics, to me at least, is the higher level stuff. Making an arm that moves faster, slower, more exactly is less interesting than making an arm that follows what the camera tells it to do. And that's going to be at a Raspberry Pi level and not at a 555 level. So when I think,
go ahead, finish.
no, I'm just saying, so when I think about what robotics means to me, robotics in rovers, okay, robotics in general could be, making very precise movements. But in rovers, it's something to do with the ability to move around, to do stuff, and therefore the higher level is more interesting.
I think that's fair for rovers anchored around like what we currently think of rovers. But I was thinking, like, if you're like trying to explore like extremely low energy or like swarms of extremely tiny rovers, it kind of might be interesting to explore how far you can get if you abandon even the Arduino level of abstraction and say, I just want like a tiny bug-sized rover that wanders around and like, I don't know, turns its LED on if the temperature rises above a point, right? That level of like, I don't know, extremely.
Even that would be easier with I would like, if you want to explore electronics, like microcontroller is a big, like a good abstractions to like a level to start with, because it gives you can either go like just use the peripherals. So there are like various modes in which you just are using the peripherals and then using some interrupts to wake up the CPU, do some work, and then go back to sleep. The CPU is mostly sleeping and the peripherals are basically doing all the work. So you can go down to that level. So basically, like you would have some sort of peripheral inside the microcontroller, like a 555 or a counter or something, and all the peripherals are doing the work. And when they are ready, they generate an interrupt to the CPU, and the CPU wakes up and then does the decision work. So, or either you can do everything in the CPU itself. So it gives a wide range. Unless, like if you want to learn the electronics part of it.
Yeah, definitely for learning electronics, you have to get modern and use, I think, microcontroller or above. And I think even for the small insect or bug-sized form factors, if energy is the main constraint, there's actually no problem in having the mostly asleep microcontroller in the background. Like if it only wakes up every few hours to do one complicated thing and the rest is done by like extremely low power stuff, maybe that's fine. So, and especially the smallest microcontrollers are like very cheap, right?
There's something called beam robotics. Have you heard about it?
I think you mentioned it before. Yeah.
Yeah, so it's basically like behavior-based robotics taken to the extreme. So it's basically the robotics evolved from like what the bugs do or like small insects do. So they will have only one function. It's like survival and then energy consumption and one more thing. And like, so they will search for sunlight and then go to the sunlight and sit there. And if the sunlight goes away, and then they will move somewhere else. So it's a robot
That's
like
basically what I was thinking. Like that's a space of maybe not rover robotics, but something like swarms that rovers can hold and kind of leave around. Like if you want like a rover that leaves the equivalent of smart pebbles around to do various things, you want it to have like a cargo hold with like hundreds of little bugs that can leave around to do various things. So that might be interesting to think about. Anyway, I just wanted to put this on people's radar as like a part of electronics kit design space that we don't think about. I wanted to throw up a couple more that I have in my workshop when I started doing this stuff. I bought this kit clock. I think it was about $10. It's So it comes with the PCB and a few chips. There's no microcontroller here. As far as I can tell, it's a clock chip, a dedicated clock chip. So this is, I think, another level somewhere between breadboard around Arduino to like 555. So it's somewhere in between, I would say. And this one is a kit a friend of mine made, and she sent it to me for free. It's based on, I guess there's a book called Circuit Classics, which has lots of classic circuits. And she made like kits for some of the sample circuits. And I think this is interesting because when I read my electronics textbook, it's like a completely alien world of what they think are the step-by-step principles you have to learn to get to useful things. And it's like very different from mechanical. If you're starting with, I'm building a robot and I need some functions to support the mechanical robot, you learn very different parts of electronics as opposed to electronics studied for its own sake. They want you to learn lots of other things. So that's something I haven't like really, I don't know, worked through, but I did buy, I think it's on, yeah, The Art of Electronics, this fat book here. I started working through it a couple of years ago, and it's like, I know the basics, but these people are fundamentally aliens. Like electronics, their priorities are like completely different from what I understand to be priorities, and maybe that's important. So there's a dual LED flasher. It's from an electronics textbook as opposed to a robotics textbook. So it tells you something that's the design they want you to build. A couple of other examples I wanted to throw in. In some sense, this is actually a kit bash. So Stratolaunch is this mothership that Virgin Galactic was using to do like atmospheric rocket launches. But this is actually, they took two Boeing 747s apart and put it together. So they need 6 engines. So they took 2 apart, they get 8. So they have 2 spares still sitting there. They sold, Virgin Galactic kind of went out of business and they sold this to another company. But yeah, the engines are from 747s. The avionics deck is from 747, and I think a bunch of other pieces. So this is like 50+% built out of 747 parts, even though you would think it's a very unique airplane. And I wanted to throw this out as well. This is built out of Cassini spare parts. So again, not many people know this, but the New Horizons mission was basically, there was a leftover radioisotope thermal generator from the Cassini mission, which uses, I think, 6 or 7 of these guys. There was one left over, so they could like build a small Pluto mission out of leftover parts from a Saturn mission, which is kind of interesting that people think in this composable modular kit way, even at like the most, I don't know, complex levels of engineering. And
does your next slide, I thought your next slide was going to have the SLS space launch system, which is all built from shuttle spare parts.
Yes, I didn't have that. That's a good one to add to this deck. But yeah, it has I think the side boosters are basically the space shuttle ones, some of the others as well. And I think the SLS itself is basically a rehash of the canceled Constellation program. So the 2009 or so, they had the Constellation program, came up with a bunch of designs, then it got canceled, then they rebooted the whole thing. But this is literally down to spare parts, like it was a spare generator left over from Cassini. Getting more virtual as looking around for things that look like kits at higher levels than hardware. And this, I think, got posted in our Astonishing Workshop storytelling channel. But yeah, animation is built out of like kit-like composable movement primitives. Right, so you have like ways characters jump or move, and that's kind of like a kit-like vocabulary for designing animations. And even at the level of like telling entire stories, apparently Warner Brothers had this 9 rules for how to tell Roadrunner versus Coyote stories. So it's like you can apply kit-like thinking to very abstract levels. And this is I was looking for like kit-like elements in the history of computing. And it turns out that the first hacker subculture in the MIT basement, it grew out of the Railroad Modeling Club. So this is in the book Hackers by Stephen Levy. What happened was MIT got PDP-1, the first true interactive mini computer. It got donated and it went to the same basement that the Railroad Club was. And the Railroad Club had 2 groups. One was interested in like, the aesthetics and nostalgia of railroads. They would try to replicate classic railroads and go on trips. But the other group was a systems group, which was interested in like the logic of the signals and systems. And they're the ones who got interested in the PDP-1 and created the original MIT hacker culture. So that's an interesting story. And the other one that I wanted to mention is the early PC revolution was entirely built out of homebrew kits. And at one point, Bill Gates got mad enough about software piracy that he wrote a nasty letter to the Bay Area Homebrew Computer Club telling them to pay for the basic interpreter. So kits are like an important part in computing history as well. So if you look at the range from like industrial mechanical kits to, I guess, radio to computers, it's like everything gets kit-like, but it gets harder and harder to make kits as you get towards, I guess, biology is the extreme that I'm thinking of, like CRISPR for doing DNA experiments is like a kit for biology. But in the range from mechanical engineering to biology, I would say computer science and like building computers is, and on a scale of 1 to 100, it's maybe 65. And it's still there, but I think basically kit-built computing is kind of dead. Like you have the framework laptop, which is MacBook equivalent, but I think of MacBooks as like basically lots of glued components and the opposite of kits. And you guys probably have built more computers and stuff than I have, but I don't know, what's your view of like kits and the actual full computers?
A phone kit came out. I think Nokia, it's called Nokia G22. So basically it's like the framework laptop, but for phones. I think it was released a month ago or something.
But it seems to me at this level, it's a little bit of a losing battle. I mean, you can build fairly capable ARPANE computers, but if you want something that's like performant comparable to MacBook, it's hard, or something that can like join regular cell networks as like a usable cell phone. Kit-built cell phones don't seem that feasible. But I don't know, maybe I'm wrong. Maybe we'll see a swing back in the pendulum where even computers can be kit-based. Software, I think Web3, you could say, has a strongly kit-like culture because it's very explicitly based around like composable elements. One that I think really fits the kit paradigm is the Gnosis DAO software tooling. So if you remember, I don't think you were part of the distributed systems calls, RET, but we were talking about like various solutions for turning discords into DAOs. And most of them out there are like, I don't know, monolithic platforms like Colony and a couple of others. But Gnosis came out with like a very interesting one where the core offering is a safe component. So the vault that we use for YC is the Gnosis vault, but they also have things like a module for voting, a module for like proposals. And it's like you can compose your DAO governance scheme in a kit-like way. And they use the word kit here, like safe starter kit. And machine learning, I think, is probably the least kit-like frontier engineering domain. But if you go to Hugging Face, yeah, data sets, model frameworks, it's vaguely kit-like. It's just not super clean, composable elements. It's more like very squishy kits. And some future time when the thing I'm doing with the Ethereum Foundation kicks off, I'll share more about the stuff I'm doing around protocols. That'll actually be public next week. But I thought this was a good sort of like motif for the difference between kits and protocols, the cabling and interface standards. I'll talk about that in a future session that I'll volunteer for. But yeah, that's my thinking on kits. Stop sharing, but yeah.
I would actually like to flip your question. What would a kit for AI look like? Well, let's put it this way. What would a kit for using ChatGPT look like? Okay, not what would a kit for building your own ChatGPT, that's, a different story. What would a kit for using, let's call it modern generative AI look like? I can imagine it would include a chat component, it would include a picture component, it would include some sort of input, like maybe a image search, and you would have some sort of glue that allows you to, put the components together.
I think that's one level of abstraction where you're composing applications. There's also the data part, right? Like prompts are a big sort of thing that the AI experimenter communities are working with, and they share prompts a lot. So you can imagine a kit coming with lots and lots of like canned recipes and prompt sequences and things like that. So there's that. When we were doing the AI workshop track of calls, I remember we played with a kit-like thing. Actually, Anuraj, I think you defined it. There's like you could train your own voice or something like that. It was a
it was Edge Impulse.
Yeah, we played with that 1 week, so that was kind of kit-like. But I think AI is fundamentally, at some level, not super kit-friendly. It's like extremely entangled. Like, what are the composability boundaries? I don't know. Like the natural way I would think you would make an AI kit is you have one trained model in one domain and you have another trained model in another domain. Can you just put them together so you have both? So you have a trained vision model and a trained audio model. Can you put them together and it becomes a trained audio-visual model? As far as I know, at an R&D level, that's an unsolved problem. Nobody's able to like bash trained models together yet in an effective way.
Yeah, but we're not trying to build something effective. We're trying to build a kit. You're building a bridge for little toy cars to go on, not for real cars. All we want to do is that you can take a trained model in one place and that it will, in a toy example, work with the next one. That kits are not, you showed kits for missions to space in the same place where you showed kits for mechano models. They're not on the same, level of expectation.
Agreed. So that's something I think to keep an eye open for. I don't know, maybe there's some sort of fundamental floor to complexity in AI, like even to run the most scaled down hobbyist level models, like stable diffusion you can run on M1 Max, I think, and that's a little bit of a strain, I believe. I have friends who've been playing and running it, but I think the minimum level of infrastructure capability to do any hands-on like AI at all is pretty high. Maybe cloud-based. Like I can imagine like something like Yahoo Pipes or a bunch of like, I don't know, functional programming type cloud-based functions.
That's exactly the same question for robotics. If you want me to do robotics at home, I have to buy quite a bit of dedicated hardware, except that maybe I can buy a Meccano set and a Raspberry Pi and maybe another 3 standard motors, and I do have a working configuration.
Yeah.
So maybe it's the same thing also with AI.
AI, I think the base component of like a sufficiently capable computer is kind of expensive. So I would say like, sufficiently good GPU for basic is.
No, I cloud. I have a cloud. Anything difficult I do on the cloud, not locally.
Yeah, and then the rest of the stuff is basically free. It's a little bit messy. You've got like, Python, PyTorch, Hugging Face has a bunch of models available for
that's not kit level. That's programming. Kit level is like in Meccano. I take a few pieces. There's a standard way of connecting them. There's only a small number of different ways I can connect them. Enough to give me flexibility, but not enough to give me, infinite possibility. It's kind of like, visual programming. But not the kind where you have a line of text where you rearrange it, but the kind where you have a box and another box, and
You know what? I think the right place for that level of like user-friendly kit components might be the peripherals. Like the Oak D is a good example. It has onboard AI, and you guys have used it, but it basically produces like recognized objects or something, right? You don't have to, I don't know, mess with it too much. Can you just do a function call and get like a list of objects and directions or something?
It's not as easy as a function call, I don't think. It's like you have to take a snippet of Python code and it will do that one particular task. And then it's programming ultimately. Like it's samples that kind of do a lot of stuff out of the box. And then as soon as you want to like integrate more than one thing together, you're back to just a programming task with a very sophisticated AI or very sophisticated API.
Yeah, I think this should be on our agenda for discussing.
Okay, so I'm getting a thought. Let me share my screen for a second here. So I put a link to KNIME, or NIME, however you say it. And NIME is a visual programming system where what you can do is you have blocks and the output from one becomes an input of another, and forget the details. Now, I'm just thinking to myself, imagine if we had a standard robotic block that included all the sensors and software components and so on, but we had this type of interface where the user says which sensors and which pieces of software actually work. Okay, so it's I'd say one level of ease or two above ROS. So, and that would be a kiddie way of doing the software part of robotics. So yeah, if you're really advanced, you could write your own little box. But if you're not, you can connect the motor box with the sensor box, and on the hardware itself, they're already connected. In other words, the electronics box that you have is a Raspberry Pi with a bus that's connected to 5 motors and 6 sensors and 7 lights and whatever. So it's already connected, so you're not rearranging the mechanical side. I should say the electronic side, but the functionality is provided with this type of interface.
Yeah, I think this kind of thing would work for non-AI programming, and I think it would extend to AI programming if it got a little richer. Have you guys used Simulink, which is this kind of like visual programming language that goes with MATLAB, and it's used to like design control systems? But all the blocks that you connected up there, it has things like, you know, control system components like integrators, differentiators, solver differential equations. So it's like you can do it that level for AI.
KNIME has some very high level components like predict and k-means. Okay, one of these boxes can be k-means.
Yeah.
Okay, but I'm thinking about robotics. I mean, we talked about AI, but we're really in the robotics call. And I'm wondering, you know, when we talk about making robotics modular kit-like, so we have the Meccano for the mechanical side, which might be too difficult for some people, but it's definitely much easier than 3D printing 50 parts and hoping they fit together. And on the software side, and on the electronic hardware side, we can have that everything is connected, but it's only activated using this type of visual kit-like software.
Yeah.
That's what I'm thinking.
And I'm now thinking, now that you've put it this way, this is actually the obvious and natural interface for things like wire harnesses and the actual cabling. So in an ideal system, if you snap together 2 mechanical components that are also 2 segments of a bus, it should show up on this diagram of you've connected the leg component to the body component. And if you want to like use the sensor and actuator of the leg, it goes down this basically conceptual circuit pathway. So that would be kind of interesting, where if you mechanically snap together the physical kit robot in your software, it'll pop up as the skeleton of the electrical and logical structure of the robot as well. Like
if you had modular electronic,
modular and
like
discoverable things, where it's like one component connects to the next and it sort of broadcasts that I'm a piece of cabling attached to like a leg spar or something like that. It's complex, but it's an interesting possibility beyond our scope, I think, but something to keep an eye open for. Anyway, we are a few minutes over time. Sorry for going over, but I'll stop the recording.